Hello friends, subscribers and new viewers of this channel, and welcome to C Programming Tutorials. In this brief tutorial, we provide a brief and concise introduction to function pointers in the C programming language. Function pointers have a number of interesting and useful applications in microcontroller programming and in scientific computing. In a recent servo control project, whose link and video are provided in the description below, we use function pointers to create callbacks and interrupt functions. Here's the motivation for creating our C and C++ tutorials and for studying C. In the age of AI, many students and people are not thoroughly studying coding anymore. We think that this is a big mistake that will eventually decrease the ability of humans to think logically, systematically, and solve problems. The purpose of this channel is to change that and to motivate people to study coding as well as to provide fundamental knowledge in robotics, control engineering, and machine learning. Here's the copyright notice. This video lesson developed code files and documents should not be copied, redistributed, or posted on public or private websites, public or private code repositories, or social media platforms. This lesson and all the provided study materials are strictly for personal use. Without the permission of the author, this lesson and the provided material should not be used for commercial purposes and for training of engineers working in companies. This lesson and the provided material should not be used as lecture materials on online learning platforms and in university courses. This lesson and the provided material should not be used to train an AI algorithm or a large language model. Okay, let's start. The main idea of function pointers is to declare a pointer to a function. Here, a pointer to a function is not the classical C or C++ pointer. The function pointer does not point to a memory location. Instead, it points to a particular function. Function pointers are very easy to use since they're not used to allocate or deallocate or free the memory. Then, similarly to ordinary C or C++ pointers, function pointers can be passed as arguments to functions. Also, they can be returned from a function. And this is the true power of function pointers that we will illustrate in the sequel. So let's start with an introductory example in order to explain how to use function pointers. Later on, we will compile and run this example. What's the purpose and motivation for presenting this example? This example will teach you how to write a minimal C code that will define a function pointer and use a function pointer. Let's start from the beginning. Over here, we declare a function that accepts an integer and returns a double value of that integer. Inside of this function, we print the message function double called, and we print this message in order to make sure that we are calling this particular function. Here's our main function. In this line, we declare a function pointer. And in the next line, we assign the value of this function pointer to be double function. That is, the function pointer will point to the double function. That is, to this function. Let's analyze this declaration and at the same time look over here at this function. First of all, this int is actually the return data type of the function pointer, and this integer has to match the data type that's returned by our original function. Then inside of this parenthesis, we are actually naming the function pointer. The name is func pointer. We use these parentheses for a very good reason. If you don't use this parenthesis, then the compiler will think that you're actually declaring a function or something similar to function, that returns a pointer to the integer. So be careful. When you see something like this is actually a function pointer. Then inside of this second parenthesis, we have the data type of the input parameters. And this data type should perfectly match the data type of our function. Once we do that, we can simply write func pointer is equal to double function. And that's it. Now, instead of using double function, we can use function pointer. And that's it. Over here, we assign the value. For example, c is equal to 5. This is our test value. We print this test value before calling the function, and here is the main call. What do we do over here? We are saying func pointer, and then we are specifying c. So what happens behind the scene? We are actually calling double function, and we are passing the value of c. Then this value will be doubled and returned the double value and stored over here in b. And finally we print b, and that's it. Let's implement this code. Okay, so let's start with coding. First of all, let's include stdio.h. So let's type include, and then let's include stdio.h. Here it is, and let's define our function. So our function looks like this: int double function. It accepts an integer number, and over here inside of the function we need to write two things. Let's type this: printf to print a message, and we'll print the message function double called. This message is used later on such that we know that we called this function. And let's return the value. We are simply return 2 times a. That's it. Simple as that. Next, let's define our int main function, and over here let's return 0. I always like to return 0. The first step is to declare function pointer. Here again, let's repeat the procedure. The return value of the function pointer should match the return value of the function. Consequently, we need to type int. Then over here, we need to open and close parentheses, and we need to name our function pointer. I will call it func pointer or f pointer. Some people like that. Then inside of the second parenthesis, we have to say that we expect to see integer as inputs. If you have several input parameters, then you will have to type, for example, here, comma, 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 how many integer or how many input parameters you expect to see. And this is very important. The next step is to type func pointer is equal to our function, double function. Here it is. Simple as that. You don't need to do anything else. And let's create a test case. So int c is equal to 5. Over here, let's print the value. The input value before calling the function, and let's print the value, and let's create a new line, and over here we need to print c, right? Then over here let's declare and define and initialize b is equal to. Now instead of calling double function, we will simply call func pointer. And that's it. And we need to pass the value of c. That is the value of 5, and the return value will be stored in b. And finally, let's print b, printf, the output value of the function pointer is. And let's do this. Let's do new line, and let's print b. And that's it. Simple as that. Nothing special. Very easy to use and very easy to explain. Next, let's compile this code. And over here, to see output in this console window, since I don't like this terminal window in Visual Studio Code, I will run it from my terminal. So the executable file is testfb1, and here it is. The input value before calling the function 5, function double called, the output value of the function pointer is 10. Perfect. Works as we expected. Okay, so let's go back to the lecture, and here's a very important thing that you should remember. Our original function and the function pointer must have the same return data type, the same number of the input parameters and input parameter data types, and this is very, very important to keep in mind. Let's start with a more interesting example. Here you will learn how to pass function pointers to C or C++ functions. So here is a problem that in some generic form can be modified and used in a number of applications. Suppose that we have a generic mathematical expression that looks like this. The result is equal to the sum of two functions, f of x plus g of x, where f of x and g of x are actually not C or C++ functions, they are mathematical functions such as sine, cosine, tan, squared, square root, etc. We want to write a C function that will compute this expression where the user provides the functions f of x and g of x. That is, the user will provide and say the following. F of x is sine, g of x is cosine, and x value is pi over 2. Or f of x is a square root, g of x is, for example, ln, and x is 1, or something similar. And we need to learn how to write this code. Okay, so let's start with coding. First of all, let's include stdio.h, and then let's include math.h. I'm including math.h since I plan to use sine and cosine functions as my test functions. Next, let's define a function that will accept a double and that will return a square of that double. So let's write double square function. The input parameter is double a, and over here we will simply return a multiplying a, and that's it. This will be another test function. Let's save this code. The next step is to define our expression function. That is, we need to define this function over here. So let's start. First of all, the function should return double. I'm going to call the function expression f, and over here we need to define, or better to say to declare and to specify, three input parameters. The first input parameter will be the function pointer to f, the second one will be the function pointer to g, and the third one will be the value x. So let's write. First of all, the output of the function parameter is, or function pointer is double. Then over here in the parentheses, let's give it a name. I will call it f pointer, where f stands for the f function. Then over here we need to specify the input parameter of this function pointer. It's going to be double. Then let's copy this and let's change the name over here to gp, where gp is a function pointer for g. And finally, let's type here double x. And here it is. The function body is super simple. We simply evaluate this expression. and we can do it in a single line, and we can type return, and now magic happens. fp of x plus gp of x, and that's it. No problems. Simple as that. Next, let's write our driver main function. Let's return 0 over here. And over here, let's first of all define the test case. Let's say double, and x should be equal to pi over 2. Now, I'm going to use pi values up to 4 digits. Here's the value of pi. It's going to be 3.1416 divided by 2. Why I'm using pi over 2? Well, you will see this in the SQL. Then I will store the result in double y. Okay, now what I will do over here, I will simply type this, y is equal to, then I will call the function expression f, and as the first parameter, I'm going to pass sine function. I can pass sine function over here since I included math.h and the sine function is defined in that header file. Similarly, I can send or specify the second input parameter to be cosine function. Again, I can use cosine since cosine is defined in math.h, and finally I need to specify or send the value of x, and that's it. Simple as that. And finally we need to print the value. And let's print the value. So let's type printf, the computed value is, and let's use the specifier for float or double. Let's use new line, and over here let's type y. That's it. Okay, good. Let's now compile this code by clicking here. Let's select the compiler. There are no problems over here. Now what I like to do, I like to go to the terminal over here, and I'm going to simply run the file from here, test fp2, and here it is. The computed value is almost 1. So now you can see why I selected pi over 2. Namely, if I'm reading this expression correctly, and I'm doing that, sine of pi over 2 is 1, and cosine of pi over 2 is 0, and consequently the result will be equal to 1. It's not exactly equal to 1 since I'm not passing the exact value of pi. However, the value is close as possible, and it's very good to illustrate the main idea. Next, let's now pass our square function to our expression f. To do that, I will redefine my x to be equal to 2. Then over here, I'm going to type y is equal to expression f, and instead of sine and cosine, I'm going to pass twice square function. So I will write square function, comma square function, and then I'm going to pass the value of x. So what will happen now? Instead of sine, over here we'll have a square function and a square function, and the result will be 2 squared plus 2 squared is equal to 8. And let's make sure that this is actually the case. Let's simply repeat the print statement, and I'm going to type here second call with change value, changed functions and value, and let's do this, and then over here we'll say the computed value is here. Simple as this, nothing special. So let's save this and let's compile this code. So let's click here to run everything and to compile, and let's go back to the terminal and let's run the file and let's see. Okay, the first value is here. The second call with changed functions and value is, the computed value is 8. It works perfectly. Okay, now before I conclude this video tutorial, there is another thing that I want to show you. Well, you can actually modify this code in a number of ways, and you can embed this code in different applications. In particular, in one of my last tutorials, whose link will be given in the description below, I'm using function pointers to define interrupt functions for microcontrollers. That is, if you want to see real-life applications of function pointers in robotics, you can watch that video tutorial. And that's all, and see you in the next video tutorial.